Hello and welcome, my dear students, to my channel Mathematics Made Easy. This is Ms. Ruchika welcoming you to today's session, especially for my grade 11 advanced math students who are going to give the EOT Term 2 exam very shortly. So here I am with another video on learning objective 18, where you will learn how to find determinants and inverses of 2x2 and 3x3 matrices. So I welcome you to today's session. We are going to solve FRQ questions. So the steps are going to be very important. Make sure you write them nicely and include as much as detail as possible for each question, whether it is a formula or an equation that you use. Put that also so that you get some bonus marks. And before we start on today's session, I would like to give you a humble reminder to please like, share and subscribe to the channel, as it motivates me to make more and more content for you. I can see on my channel analytics that most of you are liking and benefiting and watching the videos that I'm making currently for your revision for the coming term 2 exam. Please make sure you also hit the subscribe button and press the bell icon so that you don't miss any upcoming videos and get the timely notifications for my future videos. With that, let's start today's session. Okay, so let's start learning objective 18, where the first question asks us to determine whether A and B are inverses. So let's see how we are going to solve. Here I'm going to use the formula or the concept that if the two matrices A and B are inverse matrices of each other, then when I multiply them, or I take the product A multiplied by B, where A is the first matrix, B is the second matrix, or I change the order, take multiplication B with A, or product of B matrix with A matrix, where B is first, A is second, then both of them will come out to be I, or the identity matrix. Now here both the matrix that you see are 2 cross 2 order, so I'm talking about identity also, 2 rows 2 columns. Okay, so let's check one by one. I'm going to divide the screen in two parts. First we'll solve 19, then we'll go to 20. So let's check. And for this question, we are using the concept of multiplication of matrices. So I hope you have revised from my previous videos. I will link them for you in the beginning of the session today. Please watch those videos where I give the condition on multiplication, where I teach you in great detail how to multiply two matrices. So let's now do it. So first I'm going to do the product A with B. So A is the first matrix, B is the second. Order is important. So for the first matrix, let's see what's the condition. Is it true or not? What are the number of columns? 2. What are the number of rows? 2. Both are equal. So yes, we can go ahead and do multiplication. So let's write AB. AB means A is first. So first I write the A matrix, write all the numbers, then I write the B matrix. So this is the product. Okay, let's multiply. Now both are same order, 2 cross 2, so the result will also be 2 cross 2. Let's write, so means 2 rows 2 columns, 4 elements will be there. Now how I do the multiplication, very important. This is the first row, first column. So I take the first row and the first column and I do multiplication. So 12 with 3 I multiply. Maybe I want to write like this because less space. 12 with 3, and then I add minus 7 with 5. Okay, this is the first element. So if I just write it here, 12 with 3 is 36 minus 35, so it's gonna be 1. Okay, then similarly if I want to write this element, so this is the second row, first column. So I will take, let me change color, second row and first column. So multiply minus 5 with 3, minus 5 with 3, and 3 with 5. Can I say both are opposite? So 0. So minus 15 plus 15. In the next step, this determinant will come out to be 0. This is 1 already. Okay, let's go to this part now. Now this is first row, second column. So if I change color, then first row, second column. So 12 with 7. Maybe I will write here 12 with 7, and then minus 7 with 12. Okay, similarly last one, this one, second row, maybe I have to get a color. Yeah, second row, second column. So minus 5 with 7 plus 3 with 12. So I hope you are understanding how I'm doing, because here the matrix multiplication should be having the correct order. Okay, so here also we get the same thing, minus 35 plus 36, and here if you see both are opposite, so it's going to be 0. So let's write 0 1. Oh yes, we have got the correct answer. This is my identity matrix. Order is 2 cross 2. So A multiplied by B, one thing we have done till now, is equal to identity. That is true. Similarly, you need to do B with A. Now I don't have much space, so I'm going to write it here, B with A. So that means what changes? The order. So first I write B. 3 with 5, 7 with 12, and then I write A, 12 with minus 5 and minus 7 with 3. I hope you understand what's the difference between AB and BA. It's just the order. Now again, my condition for matrix multiplication is true because both are 2 cross 2. So the number of columns of the first matrix and the number of rows of the second matrix is equal. So our result will also have 2 cross 2. Now I can write nicely. There is a lot of space. So let's do it. So first I take the first row and the first column. So 3 with 12, 36, 7 with minus 5 minus this. Correct? Now if I want to take for example this, just to make you understand, this is second row, second column. So I will choose second row, second column. So what will be the number? 5 with minus 7 plus 12 with 3. I hope it makes sense. Similarly, if I want to write, say, this one, so this is second row, first column, right? So I take second row and first column. So 5 with 12 and then 12 with minus 5. So if you see these are opposites, next step it's going to be becoming 0. Okay, this one, last one. This is first row, second column. So if I choose first row, second column. So 3 with minus 7, minus 21, and 7 with 3. So plus 21. So now let's see what is the final thing. I have less space, so I'm going to write it here. So if you simplify and just use your calculator for the calculation perspective, then this will come out to be, let's write. So this is 1. This is also 1, however these two are 0, so yes, this is also identity. So for question 19, the final answer is yes, they are inverses. And what is the reason why they are inverses? Because when I take multiplication A with B, that's also I, and when I take multiplication B with A, that's also identity. So this condition is true, matrix multiplication is well defined, so these two matrices are well defined inverses. Now try for similarly question 20, and then in the next slide you can check your answer. Let's do it. I'll also do the detailed step for this one, and for the remaining questions I will want you to try yourself and then check from the answer key. So let's do. So here we need to check for these two being inverses, so definitely like the previous question I'm going to do it in two parts, the multiplication and then to check whether it is equal to identity. So let's divide the screen into, on the left I will be doing A multiplied by B, on the right we will do B multiplied by A. So let's start. So AB means first A then B. This is A and this is B. What is different here? The order. First it is B, then it is A. So let me write B first, followed by A. So I hope you understand there is a little difference when I do the multiplication. Order is definitely important. Now before we do multiplication, check condition. Now both are 2 cross 2. So multiplication will not be an issue. The condition is very well true. Let's still check it. So the number of columns here is equal to number of rows here. Number of columns equal to number of rows. Excellent. We can go ahead. Let's do it. I'll make a bigger bracket this time because we need to do the multiplication nicely, and the result is also going to be 2 cross 2. Let's fill in the blank. 1, 2, 3, 4. Now I hope you're able to understand why I made these blanks. It's just to let you know that the result that we get for the multiplication of the matrix will also have 4 elements or 2 cross 2 order. Okay, so let's do it. Now I'm going to change the color. So this is my first row, first column. So I take first row of this matrix and first column. So let's multiply 4 with minus 6 plus minus 5 with minus 5. So order is important. If you have two negatives, make sure you put your brackets correctly and don't make a mistake. Now let's come to this. So this is second row and first column. So I'm going to choose second row and first column. Let's do it. 5 with minus 6 plus minus 6 with minus 5. That's how we choose. Correct? Now let's do this. So this is first row and second column. So I choose the first row and the second column. I'm choosing different colors so that you know how we are doing it. So 4 with 5 and minus 5 with, that's how we do it. Last one, second row, second column. Again, make sure you don't make sign mistake or silly calculation mistakes and that your order is very, very correct. So let's do the final thing now. I want you to simplify. Give me, you can use your calculator as well at this point. So this is minus 24 plus 25. This is opposite, so 0, right? 5 with this is minus 30 and this is plus 30, opposite 0. Similarly here, opposite 0, 20 minus 20. And last but not the least, we have 25 minus 24. So it's so easy to identify that you are getting identity. That's what you wanted. You wanted the multiplication of A by B to be equal to identity. Similarly, I would want you to do this and it will also come out to be identity. Just fill in this now. Let's do it. First row, first column. So minus 6 with 4 plus 5 with 5. Now I'm just directly putting the numbers because you are comfortable. So minus 5 with 4 plus 4 with 5. Similarly here minus 6 with 4. So it's like first row, second column. So I will choose, let me change the number, this one with this one. So minus 6 with minus 5. 5 with minus 6, and similarly this one is second row, second column. So please simplify and check your answer, use calculator nicely, and this also is identity. So what should be your answer? Yes, they are inverses. Why? Because this condition is very well true. So my answer for this question is going to be that A and B both are inverses. Now try question 21, 22, 23, 24, and I'll give you a few minutes to try and then give you the answer key. Okay, so I hope you tried all these 4 questions. Now let me give you the answer key for question 21. When you multiply A with B, that's gonna come out to be minus 2, 0, 0 and minus 2. This is definitely not equal to identity. So therefore we can say A and B are not inverses. Okay, this is for 21. Let's go to 22. For 22, even again, when you multiply A with B, it will come out to be something which is not equal to identity. In fact, it will come out to be a 0 matrix, and this is not the condition that we want for inverses. So again, A and B are not inverses. So just do your matrix multiplication and easily you'll be able to check. However, for question 23, the condition that we want is going to be true. That is, both your A multiplied by B and your B multiplied by A will come out to be identities. So the answer will be yes, they are inverses. And for the last one, question 24, when you do A multiplied by B, this is going to come out to be 2002, which is not identity. So if it is not identity, they cannot be inverses. So therefore, A and B are not inverses. So this completes the first set of questions which are there from this part. Let's do a little bit more on the next slide. Let's similarly check the answer key for question 25 and 26. Here again, if you multiply A with B or you do B with A, both are going to be coming out to be equal to the identity. So we can safely say that A and B are inverse matrices. So I'm just now providing you the final answer because I already did in great detail for you the first 2 questions. So If it comes for FRQ, just show the steps. If it comes for MCQ, it's fine if you just give the final answer. However, for question 26, when you do A multiplied by B, that's going to be coming out to be very different from the previous questions. It's going to be this matrix. I'm putting the numbers and the values here for you. Please check your answers, and this is definitely not equal to identity, so we can safely say that A and B are not inverses. Okay, now for this one, I'd like to give you just one additional step for your information. In case this condition is true, where we say that A and B are inverse matrix, then there is another way of writing the second matrix. That means if A multiplied by B is identity, and I want to write my matrix B as matrix A, then I can move A on the other side and I can write it as A inverse. So B matrix would come out to be A inverse, or conversely, if I want to write my A matrix in terms of B, it will be B inverse. So these two things are going to come directly from this condition, that A multiplied by B or B multiplied by A is identity. So same way, same thing, same meaning, just a different way of writing. Wanted you to know this as well. Okay, let's solve now question 27. Let's read the question first. Here we have a matrix given. This is 2 cross 2 matrix. We need to find the A inverse, and we also need to check whether the matrix is singular or non-singular. So let me first tell you what is singular, non-singular matrix. So a matrix is said to be singular if its determinant value is 0, and it is said to be non-singular or invertible if the determinant value is not 0. Now, out of both of these conditions, this one is better for us, better in the sense that if the matrix is non-singular or the determinant value is not 0, it is some number, then we would say a matrix is invertible. Invertible means A inverse exists. We can find the inverse of the matrix. So this is the condition. However, if the matrix is singular, means the determinant is 0. In that case, we cannot find the inverse, and we would just say that A inverse does not exist. So these two conditions are important. Don't be confused if you see the word singular or non-singular in your exam. I've already told you the difference. So let's now find determinant of A, because that is what is very important to determine whether the inverse would exist or not. So I change the brackets, and I now do the determinant by multiplying the primary diagonal and subtract the secondary diagonal. So minus 4 will be multiplied with 3, subtract the secondary diagonal, minus 6 and 2. Now, some of you will do silly calculation mistake and forget to put brackets or do a sign mistake, so be very, very careful. So this is going to be minus 12, minus of minus is plus, so 6 with 2 is 12. Now these are opposite signs, so 0. So here if you see, the determinant value is equal to 0. So tell me, is it singular or non-singular? Yes, you're right, it's singular. And if it is singular, can I find inverse? No, not at all. So just we would say A inverse does not exist. Okay, let's move to the next question. Now we are going to solve question 29. Let's see whether this is singular or non-singular, or whether we can find the inverse or not. So let's do the same steps. First we go on to find the determinant. I will change the brackets, and now we do primary diagonal minus secondary diagonal. I hope now you know how to do it, and subtract and write the value. So let's see what this comes. 3 with 3 is 9, minus with minus is plus. So very good, this time the determinant is not 0. So if the determinant is not 0, we can say this is a non-singular matrix. And the fact that it is non-singular makes it easy for us to find A inverse. So A inverse exists. Now let me give you the formula. This is important. How do we find A inverse? There is a shortcut, there is a rule. So 1 divided by determinant of A, and then you put the square brackets for the matrix and do a change. What is that change? Let me tell you. Let me show you in fact. So you take the primary diagonal elements and you change their position. just interchange. So here it is 3, it will come at the corner. Here it is minus 3, it will go up. Okay. And for the non-primary diagonal elements, these two, just flip the sign. So if it is negative, becomes positive. If it is positive, becomes negative. So minus 2 will become plus 2 and 5 will become minus 5. As simple as that. Now put the value of A inverse. It's 1, so it's not going to change your answer. Can I say this is my final answer? Yes. So A inverse is given by this matrix. Now 1 over 1 is same as the same value. So even if you want to remove this and give this as the answer, it's perfectly going to be correct. So that's your answer. And just if you want to be double sure whether this is my correct answer or not, so what you can do, you can multiply A with A inverse. And if it comes to be identity or your 2 cross 2 singular matrix, this one, it will show you that the answer is correct. So let's just quickly cross verify this. And similarly, you can also do the opposite, which is A inverse multiplied by A. So apply the multiplication rule. I will do one for you, remaining you can do. So let's do this and check whether it is coming identity or not. So A with A inverse, that's what I'm calculating. First I write my A, which is in the question, the matrix, and A inverse I will write what I get here. So minus 3, minus 5, 2 and 3. Now start multiplying. You already know the multiplication rule. There are going to be 4 elements. So first row with first column. So 3 with minus 3 plus 5 with 2. That's the first element. There are going to be 4 elements. Let's do the next one. First row with second column. 3 with minus 5 plus 5 with 3. Similarly, minus 2 with minus 3 plus minus 3 with 2. And last but not the least, minus 2 with minus 5 plus 3 with minus 3. So how much it is? Let's see. Now I'm going to write the final thing. So 3 with 3 is 9, 5 with this is this, so 1 here. This is 0 if you see carefully. See, minus 5 with 3 minus 15, and this is plus 15. Minus plus cancel 0. Similarly here, minus 2 with minus 3 is 6, plus 6, minus 6, 0. Minus 2 with minus 5 is plus 10, minus 9, 1. So yes, this is identity. Similarly, your A inverse A will be identity. So yes, answer is correct. And final answer for A inverse is going to be minus 3, minus 5, 2 and 3. So this is how you find the inverse of the matrix 2 cross 2 and check whether it is singular or non-singular. Just to give you more practice, we'll do one more question. First, we would go and find the determinant. So if I want to find the determinant of this matrix, say I call this matrix A, then I just change the brackets and put the numbers. Now let's do the product. Primary diagonal minus secondary diagonal. So 6 with minus 2 minus of minus 5 with 3. Let's do it. So this is 6 with 2 minus 12, minus minus becomes plus. So this is not equal to 0. In fact, it is equal to 3. So the moment it is not equal to 0, we can say that A inverse exists. Yes, I can find it. This is a non-singular matrix. So let's go and do the A inverse. For that, I have already given you the shortcut of the formula. I will quickly write it again. So in this matrix, what we do, let's quickly revise the trick. The primary diagonal elements, they will change their position. So minus 2 on the top, 6 here. And the secondary diagonal elements will just change the sign. So if it is positive, becomes negative. If it is negative, becomes positive. Okay, now let's plug in the determinant value. Now, is this the final answer? I want you to think. Or there is something more you can do. Yes, you're right. You can do the multiplication of each of these 4 terms with 1 over 3. So when you do that, it's like, distributive property. So the 1 over 3 goes inside. It's like same as dividing by 3. So what do I get? Minus 2 over 3, minus 3 over 3, 5 over 3, 6 over 3. So let's give the final answer now. So value of A inverse is going to be negative 2 over 3, here 5 over 3. Now these two gets divided. Minus 3 by 3 is minus 1. 6 by 3 is 2. So this is your final answer for A inverse. If you want to be double sure, you can also do one last step where you confirm that the multiplication of A with A inverse and the multiplication of A inverse with A is also identity. So this is like the checking of the solution. Extra step, if the question asks you to do the checking, you do this also. Okay, so let's solve from learning objective 18, find determinants and inverses of 2 cross 2 and 3 cross 3 matrices. This question, it's an important FRQ where you need to show your steps nicely. The good thing about the question is that the formula is already given to you in the question itself. So if you see, this is the formula that we are going to use to find the area of the triangle. The three vertices are given by these coordinates, and the formula that we are going to be using for this question is this one. Now the matrix X is given by the matrix of the vertices. So let's first write this matrix, and then we have to find its determinant, obviously, as given in the question. So what is my x1, x2, x3? Now I can choose any points, but I have to be making sure that I choose them in the right order. Right order means I don't flip the order of the question. So for example, if I'm choosing this as the first coordinate, this is the second, this is the third, then I go in a cyclic order. That means I can't choose x1, y1 to be, let me first write so it will be easy. So x1, y1, if I choose as 1, 1, then x2, y2, I have to choose as 4, 3. So I go in the order. I can't flip the order, okay? And then x3, y3, I can choose as the third one, which is 4, minus 1. So I go like this in an order. So let's write this matrix and plug in the points. So my x1, x2, x3, the first column of this matrix is the x coordinate. So I only choose the x coordinates 1, 4, and 4. Let's write it down. Then I write the y coordinates. So this is 1, 3, and minus 1. And then finally the same value. So this is my matrix X. Now, if I want to use the formula which is given in the question here to find the area, I need to first find the determinant. So let's find determinant of this matrix X. Also, you can write it in this manner. 1, 4, 4, 1, 3, minus 1. So I hope you're able to notice, dear students, that when I change the matrix X to the determinant, I also change the brackets. So these square brackets which were there in the matrix changed to the bars, the straight bars. Now we can calculate the determinant using the formula. So I'm going to open across the first row. This is my first row, and remember the middle term changes sign. So how I open this, look here carefully. I write the first row elements with some gap in between, and for the middle term, this one, which is this first row, second column, the sign changes minus. So now I remove the row, remove the column. So if I choose this first term, then I remove the row and remove the column that contains, so these four are left. 3 minus 1, 1, 1. If I choose this middle value, I remove the row, remove the column, I'm left with these four. So it will be 4, 4, 1, 1. And if I choose the last one, I remove the row, remove the column. So I'm left with 4, 4, 3, and minus 1. Now you can use your calculator to open up this determinant, and let's go to the next slide to see what finally comes as the determinant value. Okay, so continuing from the previous slide, I'm writing the values of the three determinants. So the first was 1, then minus 1, then 1. And if I open the determinant which I got in the last value, I will just write it here. It will come out to be, or maybe I should write the determinant for an easy understanding. Okay, so I'm writing again the last step. So from the last step, if I see my determinant values, it was 3 minus 1, 1, 1. Here it was 4, 4, 1, 1. And here it was 4, 3. Yes. Now let me explain. So when I open this now, 2 cross 2 determinants we have, I first multiply the primary diagonal always, okay, and then I subtract the secondary diagonal. So let's see how we do that. So 1 minus 1 plus 1. So 3 multiplied by 1 is 3 minus of minus 1. Okay. Now I'm putting more brackets because there are various signs involved. Now this one is interesting because 4 multiply with 1 and 4 multiply with 1. Both are 4, and when we subtract it becomes 0. So in the next step this term is going to cancel. Let's see what we get in the last one. 4 with minus 1 is minus 4, and again you subtract 4 3s are 12. Okay, so as I told you, this term is going to be 0. It is gone. So here I have 3 minus of minus means plus. So 3 plus 1, 4. And from here I have a minus 16. So 1 is plus, 1 is minus. If I take it all together, it will give me a minus 12. So what is my determinant value for x? This one. Now I'm going to go back to the question and use the formula which was given. So this was the formula which was given to get the area. Now we just need to divide this minus 12. Now before I do this minus 12, let me tell you area cannot be negative, and that's why you have this absolute value or Bayer signs which only gives you positive results. So plus 12 divided by 2, that's 6. So what is the final answer? The area of the triangle is given by 6 square units. That's the area. So this is how an FRQ has to be done, showing all the steps. And if you want more details how to find the determinant, I will just put towards the beginning of this one a video from my channel which has all the steps that you need to find determinants of 3 cross 3 matrix. Okay, moving on, let's do one more question of the same type. This is my next question, and now I'm going to go a little fast because I've told you in great detail how to reach to the answer. So directly we are now going to plug in here. So A is going to be 1 by 2. Let's put the value of determinant. So if I choose 1, 2, 3 in this order, then 1, 6, 2 is my first values of x. Then I take values of y. So 6, 4, 2. Sorry, 6, 4, 0. Yeah, I will just change it. And then the last one is 1, 1. So how did I choose? I choose my x1, y1 to be this point 1, 6, x2, y2 to be this point 6, 4, and x3, y3 to be my third coordinate, which is 2, 0. So I hope this makes sense. 1, 6, 2, first column, 6, 4, 0, and finally. Okay, now we are going to go fast, use calculator. So I'm going to break this on the first part. So 1 minus 6 and 1. This I already explained you. Remove this row, remove this column. So in the first part, now there will be a lot of brackets involved, so be very careful with your calculations. I'm putting the determinants first so that we just now need to plug in the numbers. So when I take 1, I remove this row, remove this column. So these 4, 0, 1, 1. When I take the middle number, negative sign, remove the row, remove the column. These are the numbers left. So let's write 6, 2, 1, 1. When I take 1, the last one, remove the first row, remove the third column. I got this. Now I hope you're getting what we are doing here, and now it just remains to open the determinants and reach to the answer. So I'm going to open it here. First primary diagonal, subtract secondary diagonal. So let's do that. Okay, so the first term 4 with 1 is 4. This is 0, so just a 4. The second term minus 6. 6 with 1 is 6 minus 2. So 6 minus 2 is 4. The last term 0 minus of 8. Okay, not to forget the absolute value because area cannot be negative. So the next step would lead us to, let's use our calculator. 6 4s are 24. This is minus. So 4 minus 24 minus 8. One more step to simplify and then we get our answer. So I just combine the negative with negative, subtract. So 4 minus 32. Absolute value means I do the subtraction. So this is minus 28 absolute value divided by 2. So I get positive answer 14 square. So this is how you get your answer. Final answer for this question. Okay, I hope this makes sense now. I would want you to try more questions of similar type yourself. I'll be providing towards the end of the video the answer key for the remaining questions. So as promised, I'm providing you now the answer key for remaining questions 47, 48. For question 47, the final area for the triangle would come out to be 13.5 square units. And for question 48, the area would come out to be 9 square units. With that, we have come to the end of question 18 or learning objective 18, in which you learned how to find the determinants and inverses of 2 cross 2 and 3 cross 3 matrices, and also the formula to find the determinant to use the determinant and find the area of a triangle. I hope this video was helpful for you, and if it helped you, give it a thumbs up, like, share and subscribe to the channel, and let me know in the comment section if you have any questions or queries, or which video or which topic you want me to cover next in my upcoming video. Until then, this is Ms. Ruchika signing off from my channel, Mathematics Made Easy. Seeing you in my next video. Bye, students. Before we end this video, a humble reminder from my side, a gentle polite request to please subscribe to the channel if you're finding the videos useful, so that you get the notifications for my upcoming revision videos. It serves as a motivation for me to make more videos apart from my personal time to help you all who are going to give the grade 11 and the grade 10 advanced exams. All the best.